morning children. Welcome back to your chemistry class. So today we are going to study about some other properties in which we are going to observe periodicity, right? For example, we are going to talk about atomic volume, density, melting and boiling point, valency, all these things today in this periodic table. So let us begin with the first point, that is atomic volume. So atomic volume, it always increases in a group from top to bottom. Okay, increases in a group. Now why does it increase in a group? Because the number of shells increase. Because number of shells increase as we go down the group. Clear? Then in a period, what do we know in a period? From left to right, the atomic volume will vary. Okay? In a period, it varies. Now how? It first decreases. It decreases at first for certain elements and then becomes minimum in the middle and then again increases. Okay. So there are two factors on which this depends upon its variation in the period. What are they? First point, atomic radii decreases due to increase of nuclear charge. Okay, this point is clear. Atomic radii is decreasing. Why? Because there is increase in the nuclear charge. This we have already studied in the period. And the second reason why it shows variation is that the number of valency electrons increases in a period. Clear? So over here, to accommodate all the valency electrons, the volume will always increase. So these two factors, they oppose each other. The effect of the first factor, that is atomic radii decreasing due to increase in the nuclear charge, right? This is more on the left side, and on the right side, the second part plays more important role. Okay, so this is more important on the left side of the period and the second one is more highlighted in the right side of the period. Okay, and therefore we see the variation in the period. Fine. So this was all about your atomic volume. Now let's talk about density. The density of the elements in solid state, it varies periodically with their atomic numbers. At first the density increases gradually in a period. Okay, in a period it first gradually increases, right, and then becomes increases, then in the center somewhere in the center becomes maximum and then again starts decreasing. Clear? So in solids, you can take an example like osmium, right? It has the highest density, that is 22.6. and in liquids mercury has the highest density. Okay, mercury has the highest density of 13.6. These are the highest densities. This is in case of solid and this is in case of liquid, right? Melting point and boiling point. And melting point and boiling point. The melting point of the element, the melting points of the elements, they exhibit some periodicity with the rise of atomic number. So what has been observed? It has been observed that elements with low values of atomic volumes, they have high melting points. Okay, so over here elements with low atomic volume have high melting point. Okay, while elements with higher values of atomic volumes, they have low melting point, and high atomic volumes have low melting point. Is this point very clear to you? In melting and boiling point, elements with low atomic volumes, they have high melting point, and elements with high atomic volume, they have low melting points. Okay, so melting points of elements in any period, at first it increases. In a period, it first increases, becomes maximum, right? In the center, and thereafter what happens? Thereafter starts decreasing. I hope this point is very clear. First it increases, at the center somewhere it is maximum, and again it starts decreasing till the end. So the melting points of the elements this was about melting point. Same thing we are going to observe in the boiling point also. That is, in a period, the boiling point first increases and then becomes maximum in the center, and thereafter it starts decreasing. Now in a group, what will happen? This was also for the boiling point, right? Now in a group, what happens? The melting and boiling point, they do show regular gradation. How? The pattern of the variation is different in different groups. Remember, for example, in alkali group, that is 1A, the melting and boiling point, it decreases as we go from top to bottom. But what happens in halogens? There is just the opposite. There is increase in moving from top to bottom, right? So there is a variation over here. So I'll write it down that in a group, melting point and boiling point show show regular gradation, right? However, the pattern of variation is different. Clear? What was the pattern I told you? Like example, alkali group. What do we see over here? Melting point and boiling point decreases from top to bottom. But in halogens, what do we see? The melting point and boiling point increases as we go down the group. Okay. So let's take some examples over here, like tungsten. Tungsten, it has maximum melting point, right, amongst the metals, and carbon has the highest melting point among the non-metals. This is a metal, okay, and carbon with amongst the non-metals also has the maximum melting point, both of these, right? Helium, it has the lowest. Helium has lowest melting and boiling point. Clear? So this is what we need to study about melting and boiling point. Next we are going to talk about valency. You know what is valency? It is the combining capacity of an element. Now let us talk about valency. What is valency? Valency is a combining capacity of an element, right? It is a number of electrons lost, gained or shared during a chemical reaction. Therefore, the valency of electron is what? It is linked with the number of electrons that are present in the outermost shell of an atom. Thus, we can say the electrons that are present in the outermost shell, they are, what are they called as? They are also termed as valence electrons. So, in case of representative elements, right, the valency is generally equal to the number of valence electrons. Valency is equal to number of valence electrons, okay, or you may say they're equal to 8 minus the valence electrons, or 8 minus the valence electrons, right? Whereas in transition elements, where are transition elements? The D block elements, okay? These are the transition elements. How do we find out the valency? They show variable valency. They show variable valency. The common valency of transition metals are what? Common valency of transition elements are 2 or 3. Okay. Now, this is, we are talking about valency in a period. In a period. What do we know? What happens with the valency in a period? It increases from 1 to 8, from left to right in a period, okay? But on hydrogen scale, let's look for some examples for at hydrogen scale. That is, say if I take the third period elements with the compound NaH or MgH2 or AlH3 or SiH4 or PH3, H2S and HCl is the last one. So over here, what are we going to observe about the valency? Here it is 1, then here it is 2, Here it is 3, then here 4. Now here what? 3, 2, 1. So what did we understand? On the hydrogen scale, the valency first increases from 1 to 4 and then decreases from 4 to 0. 0, where will it go? It will go to the inert gas, right? Whereas if we talk about on oxygen scale, let's talk about on oxygen scale. Write down the compounds like Na2O, MgO, Al2O3, SiO2, P2O5, then SO3 or Cl2O3. Now let's look at the valency over here. It is 1, then 2, then 3, then 4, then 5, then 6, then 7, and so on. So what did I tell you? That it increases in a period. Generally it increases from 1 to 8, right? Which also we can say it happens on the oxygen scale. But if we study the hydrogen scale, what will we study about the valency? That it first increases from 1 to 4 and then decreases to 0. This happens in period. Now in a group, what do we know about valency in a group? All the elements, they have same number of valence electrons, and hence all the electrons, they show same valency. They have same valency. If you remember the first group, lithium, sodium, potassium, rubidium, this was 2-1, this is 2-8-1, 2-8-8-1. So what are we seeing? They all are going to lose one electron to become stable. So what is their valency? It will be +1. Therefore, all the elements found in a group, in the particular group, they have same valency. Clear? I hope till here it is very clear. Now let's talk about the fifth point, about the nature of oxides. Right? In period. In period, what do you observe? In a period of the nature of the oxide, it varies from basic oxide to acidic oxides. I hope this is very clear to you, right? And in a group, what happens? In a group, the basic nature increases, or you may say that the acidic nature decreases. Okay? Basic nature increases, right? Oxides of metals, they are generally basic, and oxides of non-metals, they are acidic. I hope you all know that. So I'll write it down somewhere over here. Oxides of metals, what are they termed as? They are basic oxides. Okay, basic oxides. And oxides of non-metals, what are they? They are acidic oxides. Followed, amphoteric metals. What are amphoteric metals? They are like aluminium, zinc, Mp. These are all your amphoteric metals, and their oxides are termed as amphoteric oxides. That when an element forms number of oxides, okay, then the acidic nature, increases as the percentage of oxygen increases. Clear? Some very important points I am telling you. What did I say? That when an element forms number of oxides, then its acidic nature will increase as the percentage of oxygen increases. So let's take certain examples like N2O, NO, N2O3, NO2, N2O5. What did I say? When an element forms number of oxides. Can you see number of oxides? Then acidic nature increases as the percentage of oxygen increases. Where is the percentage of oxygen? Here you will find the percentages 2, 3 and 5. So what are these? These are acidic in nature. Okay. And what about these two? They are neutral because they have simply one oxygen left over here. Okay. Let's talk about another example like P2O3, P2O4, P2O5. So which one is most acidic? Definitely P2O5 is most acidic. So what do we say? As we go down, the acidic nature increases. Acidic nature increases. Why? Because this is most acidic. Clear? Take one more example like MnO, Mn2O3, MnO2, MnO3 and Mn2O7. Now, according to the point that I have told you, when an element forms number of oxides, then the acidic nature increases as the percentage of oxygen increases. So which one is acidic? Who can tell me? This has maximum number of oxygen, so this is acidic, isn't it? This also is acidic because it also has maximum number of oxygen present over here. Now, which one will be most basic? Because least oxygen present here, so this becomes your basic. This is also basic. Then between basic and acidic, what should you get? You should get amphoteric oxides or neutral oxides. So here, this one is your neutral manganese oxide, that is MnO2. Okay, this one is the neutral one, right? Now, some examples like carbon monoxide, N2O, NO, water. What kind of oxides are these? These are neutral oxides. Fine. Then let's talk about certain acid anhydrides. So, let us understand how are acids formed. You should be knowing that when your acid anhydride, they are also termed as acid anhydride. Okay. What are they also termed as? Acid anhydride. When they dissolve in water, then they give us acids like H2O plus CO2 will give H2CO3. SO2 plus H2O will give H2SO3. P2O5 plus H2O will give H3PO4. Is this clear to all of you? That is, what are we seeing over here? That all the, what are these called as? Acid anhydrides. Okay, these are termed as acid anhydrides, which when dissolved in water they give us acids. Now let's talk about the nature of oxyacids, right? So I hope you know what are oxyacids, all those acids which contain oxygen in them. So let us understand their trend. The strength of the oxyacids formed by non-metal, it increases from left to right. What it? This increases from left to right. Okay. The nature of oxyacid, it increases from left to right. Let's take few examples. Like in the second period, we have H3BO3, we have H2CO3, we have HNO3. So what is happening? Look over here. The strength is increasing. Which one is more strong acid? HNO3 instead of H3BO3. Then let's go to the third period and check. Then the first acid that will be formed will be H2SiO3. Then it will be H3PO4. Then H2SO4. Then HClO4. Okay. So over here also what are we going to see? The strength is increasing. Right. Now let's talk about in a group. In a group, what happens? The strength of oxy acids of non-metal decreases. The strength of the oxy acids of non-metals decreases. Okay. For example, if you take the fifth group, what oxy acids are you going to form over there? It is HNO3, H3PO4 or H3ASO4. Okay. So what are we studying over here? Again, the strength increases this side. Right. So if a non-metal forms number of oxy acids, then what? Then the strength increases with the increase in the percentage of sulfur. Do remember that. Let us discuss some anomalous properties of second period elements. Okay. So reasons over here. Anomalous property. What are the reasons? Firstly, small size of the first member. This is one reason. Second could be like there are large charge or radius ratio, right? Then they have high electronegativity. Then the fourth one is there is absence of d orbitals. Okay, there is absence of d orbitals. Only what we can say 1 2s and 3 2p orbitals are present in the valence shell. Okay, so I hope this is very clear to you. The anomalous properties, you should be knowing the properties of the second period group, and then what are the anomalous properties there. These are some of the reasons why we see the anomalous properties in the second period. What are they? That small size of the first member, then maybe the large charge or the radius ratio we are talking about, or high electronegativity, or the absence of d orbitals, right? So we wind up over here. With this we finish off with the chapter also. Thank you.